Okay, so now let's get into the business of what does a recursive formula look like and how do we go about writing it. So I have the same sequence that we were looking at in the previous video, and now I want you to understand the basic foundations of writing a recursive formula. If you understand the concept of this, to get the new term, now instead of writing new, I'm going to write next term. But we can say the word new. To get the new or the next term, what I'm going to do is I'm going to take the previous term and add 3. Now the reason we're adding 3 is that this sequence was growing by adding 3 from one term to the next, as we saw again in that last video. To get the new term, you take the previous term and you add 3. That in essence is a recursive formula. The trouble with it is it's not written in the symbols that we use in algebra. It's more or less written in a sensible way. I realize that makes it seem like algebra isn't sensible, but it is if you look at it a little more closely. So now here's the thing. We know how to say any term in a sequence. Any term in a sequence would be a sub n, right? That would be the any term. We also know how to say the first term in a sequence. The first term in a sequence would be a sub 1. We know how to say the second term. The second term would be a sub 2. We know how to say the third term. The third term would be a sub 3, etc. We could count first, second, third up to the any term and say a sub n. And we could say the term after the any term. What term would be after a sub n? You know what would be after the third term. The n value would change to 4. Well, how do you get from 3 to 4? Well, you just add 1 to 3. So you get your a sub 4 by basically saying, oh, I know I add 1 to the 3. That's how I'm going to get my 4. So if I wanted the term after a sub n, I would say it's a sub n minus 1. If I wanted, a sub n plus 1, because I'm going to add 1 to it. If I want the term after that one, I need to add another 1 to this n plus 1. So I would have a sub n plus 2, and etc. This could go on. So any term, to get any term in the sequence, any term in the sequence is going to be a sub n. And it's going to equal the previous term plus 3. Now I have to figure out how to write the previous term. Well, if I want to know what's the term before the 47th term, you would know it's the 46th term. Well, how do you get from 47 to 46? You just take 1 off. What's the term before the 83rd term? The term before the 83rd term is going to be the 82nd term. So now I'm asking you in essence to tell me what's the term before a sub n. So we're going to use the same idea that we use to get the terms after. Well, to get the terms after, we add 1. To get the terms before, we subtract 1. So a sub n is the term before a sub n minus 1 is the term before a sub n. If I want the term before that, which I actually don't need it to write this recursive formula for that sequence, I have to take 1 off of a sub n minus 1. I have to take 1 away from that n minus 1. When I take 1 away from it, I'm going to get a sub n minus 2. This is the term that's 2 terms before this term. This is the term that's 1 term before that term. This is the term 1 term after that. This is the term 2 terms after that. So how do I say the term before a sub n? I say a sub n minus 1. And if you realize what's going on here, this is any term in the sequence, and this is the term before that one. So this is saying any term in the sequence is the term before it plus 3. I don't want you to read this as a sub n. I want you to see it as meaning any term. I don't want you to read that as a sub n minus 1. I want you to read that as the term before it, or the previous term. So any term is the previous term plus 3. Well, that's basically how we're going to find the next terms in the sequence. Now there's a problem with this. If I told you that this right here was the formula for this sequence, there's a problem. And the problem is, do you know what you start with? If you just saw that formula, how on earth would you know you start with the first term being 16? You don't. It just says any term is the previous term plus 3. So the first term could be anything. So the other part of the recursive formula, this is only one part of it. The other part of it defines what the first term is. So a recursive formula looks like this. A sub 1, that says the first term for this one is 16. And then the rest of it is, you say, any term is the term before it plus 3. Very often you'll see it written with a little brace. Sometimes there's no brace written. But in essence, right there, that is the recursive formula for this. I realize it looks confusing, but if you understand, this just means the first term is 16, and any term is the previous term plus 3. If you start thinking of them that way, they'll be a little easier to read. Now, the authors of your textbook don't write them this way. I like to write them this way. To me, I think it separates, this is what the first term is, and this is how you get the next term. The authors of your textbook write their sequence, their recursive formula for sequences this way. They write the first term is 16, comma, the new term is the previous term plus 3. They write it in one line. I like to write it in 2, they write it in 1. So when I see them written in 1, I typically will rewrite it in 2 because I just think it makes it stand out. It can also be written using function notation this way. F of n, oh sorry, not f of n, f of 1 is 16, and f of n is f of n minus 1 plus 3. Where this says the first value of the function is 16. The first value of the function is 16, and any other value of the function is the previous value of the function, which is all of this, plus 3. It says the same thing, it's just a different notation.